So to kick off our particle sim, we are going to create another geometry object. Going to dive into that, and we're going to make ourselves a sphere. And we're going to move the sphere up. So also we are going to change it from a primitive to a polygon. I always up the frequency. And so we are just going to create a simple pop network. So right off the bat, you can see that points have been scattered onto the surface. And it fills up and doesn't really do anything. That's because of a bunch of things. So first of all, there's no gravity in this pop sim. So we're going to add some. So now if we go, things will fall, and they'll just keep falling and falling forever. So one thing that we're going to do is we are going to change the lifespan of these particles. So by default, when you create a pop net, it goes birth. Its life expectancy is 100, which means it's probably never going to die in your scene. Frame ranges just don't last long enough for 100 to really matter. So we're going to change it to 1 and see what happens. So now you can see that all these particles are dying after 1 second, or 24 frames. You can see if I scrub through this, it'll start dying right here. So one way that we could change this up is we can give it a variance. And so now I can say you're going to live plus or minus half a second. And that's okay. It's a fine way to go about things, I guess. But I don't really like working like that. I want to give a very specific number in which things live. And this is sort of a weird way to just give a number in front of and after a number. So we're going to do it with a wrangle. So we're going to create a pop wrangle. So I'm just going to set this to 1. Set this as 100, doesn't really matter. Because we are going to create our own lifespan. And so if you go here and hover over, you can see that this parameter is life. And we are going to use that parameter, so it already exists. So now we are going to say at life equals rand. So one thing that we're going to use in pop networks that we absolutely must do is, instead of using ptnum, we will be using at id. And by default, every particle when it's birthed in a particle simulation has an ID. And the reason for this is because when particles die, as I had mentioned before, it reassigns that point number to a different particle that's been birthed. So point numbers are just constantly changing. You can't keep anything consistent. So you need an ID that's a unique number that will always be that particle's. It will never change. So now we're going to do rand ID. And so this, if I just leave it as is going to be a number from 0 to 1. So some particles are living 0 seconds. Some are living a full 24 frames. But again, this is just from 0 to 1. So now we have to do what we've done before and do fit 0, 1 rand ID. And then in here we can again make a min and a max. So let's say I want some particles to only live 0.1, and I want some particles to live, let's say, 1.5. More on that. And now you can see that 1.5, or A second and a half, 24 plus 12 is 36. So we can see that particles start dying around frame 36. So now I have a lot more control over how things are going to live. But I had mentioned this before, especially with particles, you don't want things to have a perfect distribution of lifespan. We don't want it to be evenly distributed between 0.1 and 1.5. So this is where we use our ramp. So we are going to do ch ramp, going to name it life ramp, and we are going to fit this random function, and now we're going to have a spline. So you can see this is a much different distribution than what it was before. Alright, so now that we have life sorted out, we want to change how it's emitted. And so the way that particles are emitted is that they inherit the velocity of the point that they are birthed from. And right now there is no velocity. So we can do a few things for this. First, we can make a point wrangle. And on here, we can just say at velocity equals, let's say it's just going to the right. Now if we go in here and start emitting, everything is going a bit to the right. And gravity's dragging it down, but you can see that everything is shifting over. And that is certainly a way to create velocity. Rarely is it that simple. Let's say we want things just shooting outward in every direction. Well, we can do this. We can create a facet. And a facet, we will pre-compute the normals. Now we can see that we have normals. And let's get rid of our velocity attribute for now. Now what we can do is we can say that our velocity is now our normal. And so the velocity is always going to be going in the direction that the normal is facing. If we go here now, we can see that things are going out in every direction. They need to fight gravity, but they are going out in every direction. But let's say we want them to go out further. Okay, we can do that pretty easily. We can say, well, let's do this first. We're going to manipulate just the normal. So at n times equals mult. So we're just going to multiply onto the normal that we have. So if we view normals here, right now it's going to be 0. If I make it 1, then now we just have normal length to normals. But let's say I want really long normals, so 5. And so then now the velocity is going to be the same as the normals times 5. So velocity times 5 will give us this. So it's all pretty standard. It's all coming out in the same speed. So let's say we want to vary how the speed is per point. Well, we can change that by, let's do at n equals fit 0, 1 rand pt num channel float min channel float max. So what we want to do is multiply the normals that we have by a random number. And let's say we make this 4 and this 1. So now we have a variance of different normals. And so the reason I'm doing this on normals instead of using just the velocity attribute itself is, for some reason in Houdini, if you look at the velocity, instead of it facing outward in the direction it's going, it has trailing velocity. that visually just doesn't mean a whole lot to me. I don't like it, so I don't use it. So I do everything with normals. This is a lot easier to see than this. So this is what I use, and it serves the same basic function. So now I have a variance of different normal lengths that are then turned into my velocity. And let's turn down the mult of this. We're just going to make it times 1. No. Huh. Oh yeah, we are not multiplying anymore. So let's see what this looks like. Whoa. So now they're all coming out at varying speeds. I'll just set this to real time. And you can see that now it's way more varied in how this is being emitted from the object. So another thing that we could do is have it so the way that it's emitted is spinning. And you'll see what I mean in a second. So let's say I want this to be facing something that's orbiting around the sphere. I can make another sphere. I'm going to transform it. I'm going to translate it out a ways. -10. I'm going to translate it up. Let's say 10. And then now I'm going to just start spinning it around. So one thing I can do is I can just say, I want you to rotate by time. Time is a pretty small number and things need to rotate in degrees. So to rotate all the way around, it needs to be 360, which means we need a larger number. So we need to take time and multiply it by, let's say, 45. So now if we scrub through here, you can see that it's orbiting. I still want it to go faster, so I'm going to say 75. So yeah, that'll do for now. So, how can I get these normals of this sphere here to face this sphere? Well, we're going to do a point wrangle. So I'm going to plug this into input 0 and this into input 1. Now I'm going to say at n equals the point position of input 1, so p. So I'm going to say 0 because there's only one point that I need to reference, and it is the first point, which is 0. And I'm going to do minus p. And now you can see that all my normals are facing that sphere. So if I play this, it's going to rotate around with it. And then we'll just kind of do what we did before. I want to vary up how these things are being emitted. So I'm going to do at n times equals fit 0, 1, rand pt num, make that 4. That's too much, let's say 2. I want to be able to multiply all of these by as much as I want, so I'll just do mult. And then we'll convert these normals into velocity. And gotta make that. Gonna make this 1 for now. So now, when we emit from this, we'll be doing that. And if you notice some stepping, it's because we need more substeps. You can kind of see some banding here. So one thing that'll help with that is if we just go to the simulation, change this to 2. Let's try 3 for now. And there. No banding. And now the sphere is chasing after, well, these points are chasing after the sphere.